Now what we have is we have a table here, a template, if you will. And with this template, we're showing the order because everything does not go as simple as we showed on the periodic table. There's some exceptions. So this is referred to, and I refer to it as the most recently added, and Aufbau is building outward. Now what that means is that we can take one element and we can just assume that we have the next one by adding one electron to the electronic structure, and we can get the structure. So here we have a template, and you can go right on through, and we're not going to go all the way through these, but I want you to understand some of the exceptions, and especially they work around usually the S and the P, or down here they work between the S and the D, and there are a number of exceptions you can see in here. But again, we're going to just look at some and let you see what's going on. Now let's just review the orbitals again. S orbital is spherical. It's the lowest energy of the ones. You have one of those, so you can have the two electrons. So over here, where we've got one S, we can have one S1, which would be hydrogen, one S2, which would be helium. That's the noble element. And we'll go to the 2S, then to the P's, and once you fill up the P again, you've got a noble element, so it goes to the S. Now, no problem there. But here we do the S, and we go to the P, and again, once the P is filled, you have a noble element, so we don't go to the D, we go to the 3S, and then we go back and pick up, we go to the 4S, and then we'll go back to the 3D, and this is going to happen throughout. We'll get to the S because it's the lower energy and field first. The P orbitals, the 3 P orbitals, I like to use these Easter egg models I put together. The P orbitals, this would be a P, and it's just shaped. Now keep in mind that these areas are basically vacant. The electron is going to occupy negligible space. So you cannot see this P orbital as being a solid like I have it here. But this is the volume it's going to carve out. The P has two equal lobes, T equal lobes, and so these are equal in size and shape. And so one electron would go into this P, then you get another one into this one, and one into this one. So you're expected to know that if you got a 2s2, 2p3 atom, that those electrons are not 2 and 1, they're 1, 1, and 1. The D, there are 5 D orbitals in equal energy, but there are 4 of them that has like a clover leaf distribution. And there's one that sort of fits in like a P with the donuts and areas. So the 5 of these are equal energy, but you can see that the shape's not different. So I think that's what happens when we begin to see some of these exceptions. Get in all the way down here, but we'll talk about it. So we can come through 1s, 2s, 2p, no problem. 3s, 3p. You also have a 3D, but that is not filled after the P. You always go back to an S after a P, after the noble element. So now what happens is, for element 19 here, these are going to be filled with electrons. Each orbital has 2, and then the next electron goes into the spherical on the outer limits, and that's the reason this electron is easy to remove, because now you go on out to another layer, and it's on the outer extremities of the atom, and there's not as much pull from the nuclear core, of course. And so this one is going to be very reactive. This is potassium metal, an active metal over in column 1. So once it's filled in, you do not go to the P, you have to go in and fill in, or you go back and fill in the D's. But everything's not as smooth as we would like to have. So as we go through this, we can have one electron in this 4s, then another one in the 4s, that'd be element 20, and then we start filling the D's. 21, put one in here, 22, 23, and 24. Now, if that just stayed as it is, you'd have 4s2, 3d4. But that's not what happens. There are 5 degenerate orbitals here, and you've got one vacant and the others are occupied. So what happens that's energy favorable, that one of these electrons is going to move from this 4s into the 3d, and now you have one electron in each one, and that's a better arrangement than what you had the other way. So you're going to have 4s1, 3d5, and that's the structure that we have for element for chromium for element 24. Okay, so now we have one, and that's one of the exceptions. So it's unusual because it's got one electron in the 4s1 orbital. Now we go back, and where does the next electron go? Well, you've got one in each one of these, and if you added one to here, it'd make them uneven again. And so instead of going in here, the s orbital is spherical whether you have one electron or two, so element 25 electron goes back into the 4s. So now for element 25 you have 4s2, 3d5. So what's going to happen with the next one? Well, the next electron is, instead of going into the P or somewhere else, it's going to start filling up with 2 electrons this d orbital. So 26 is going to have 4s2 and 3d. Keep in mind you had 5 already, so 3d6. So you got 2 electrons in this one, 1. And so then you keep adding. You go from 26, 27, you have 2, 28, 29. Now if you think about it, we're sort of back to the same situation we had earlier with element 29, because now we've got 2, 2, 2, 2, and we have 1. So again, those are unbalanced, if you will. And what's going to happen again is, for element 29, one of these 2 electrons in the 4s is going to move into here. So now you have 2 in each one of the d orbitals. You have 2 electrons. You got, and you only have 1 in the 4s. So for element number 29, you're going to have 4s1, 3d10. And that's the structure you have. So again, you have 1 electron in this orbital here, and that's one that's going to be easy to remove, this one here, if you just have the 1 electron in there. And so that's what's going to happen with the exceptions. What is next? What is next? You have the 4s, and then you go to the 4p. 4s, after you do the 3d, you go to the 4s, then you go back, the transition, and you pick up the 3d. Now you fill up the p's, the 4p. And again, you put 1, 1, 1, 2, 2, 2, and you're back to another noble element. So anytime you get to a p, the next one it fills is going to be an s. So you've got 4s, 3d, and then the 4s. Then you jump down to the 5s, and we're going to take and put electrons in there, 1 and then 2. And you can see that there's a number of exceptions going on here. It seems that there seems to be some play about the fact that these orbitals already have the same energy, the 4 of them like this and 1 like this, and as they get more pull from the nucleus and the higher atomic number, seems to be more interplay with these exceptions here. So that's what these arrows are. You can go to Create Space or Amazon Books, and I have this in a little book I put together. It's on Amazon Books.